So section 4B, part 2. We left off with looking at exponential growth and deciding where maybe a graph earning a particular amount of interest might be placed with respect to two other graphs. Let's continue in 4A with a formula. And this is a formula for compound interest when your interest is compounded n times per year. That means it's not compounded once a year, but it might be 4 times or 3 times or 365 times a year. So the value of n represents the number of compoundings. This formula will be given to you, so you won't need to memorize it, but you do need to know what these variables stand for. So the formula looks like this. A is equal to P, then a set of parentheses, and inside that parentheses we have 1 plus a fraction. And that fraction is APR divided by N. We close that parenthesis, and that amount in that parenthesis is raised to a power. And that power is N times Y. Now remember, I'm going to give you the formula. You just need to know how to use it. And you need to know what these variables represent. So A, on the left-hand side, is your accumulated balance after so many years. It's sometimes called the future value. What's my investment going to be in the future? P is that starting principal, that initial investment that you make, and it's sometimes called present value. What is my investment, or what is the amount of my investment presently that I'm putting into this account? APR is the annual percentage rate, and you have to change it to a decimal. So if my percentage rate is 7.5%, I have to convert that to a decimal as 0.075. Always, always very important. Y is the number of years you're going to leave your money in the account, and it doesn't necessarily have to be an integer. If you only leave it in for 6 months, then Y would be 0.5 or 1/2. Last variable is N. N is the number of compoundings per year. So how many times a year are they going to compound your interest? Well, it varies depending on the statement in the problem. So if interest is compounded quarterly, that means the value of N is 4. That's 4 times a year. If interest is compounded daily, then the value of N becomes 365. That's 365 times a year. Monthly would be the value of 12 for the variable N. Annually, once a year. And semi-annually would be twice a year. The value of N would be 2. So we need to obtain that information from the problem. And as we mentioned earlier, the rapid growth of an investment that earns compound interest is called exponential growth. So here's a problem where you're going to use that formula. So we're looking at a mattress investment. Well, what's that? Well, that's putting money under your mattress. So suppose your grandfather placed $100 under his mattress 50 years ago. How much money would he have today? Just $100 that he put under the mattress 50 years ago. Now suppose he had instead invested it in a bank account that paid 3.5% interest compounded yearly. How much would it be worth now? Well, I can use that formula we just mentioned. But we need to pull out our variables. So the $100 that was stuffed under the mattress is your principal, P. Leaving it under there for 50 years is the value for Y, the number of years. The 3.5% interest is your APR, your annual percentage rate, but it must be written as a decimal, 0.035. And it says the interest is compounded yearly, which means the value of N is equal to 1. So you want to write down the formula that I mentioned earlier. A is equal to P times parentheses, 1 plus APR divided by N, close the parenthesis, all that parenthesis part raised to the N times Y power. Once you sprinkle in all the numbers and their positions, you'll need to use your calculator to figure out this value. I suggest if you don't have a fancy scientific calculator, determine what the value is inside the parentheses first. Take that, because we have to use the order of operations, sorry. Take that number and raise it to whatever the n times y power is. So you're going to have a raise to a power button on your calculator. And it usually looks like this. On your calculator, you might see an x raised to a y power or a y raised to an x. That's the button you use to raise to a power. Or you might see a caret button, which is an upside down V. That's also another way you can raise to a power. So sprinkle in all the numbers, see what you get. So did you determine that value, plugging in the numbers into your calculator? You should get $558.49. So had your grandfather put that money in the bank rather than under his mattress, it wouldn't be worth $100. It would be worth $558.49 at the end of 50 years. Notice in my formula I put 100 for the principal, 0.035 as the APR, the value of 1 for N, and the value of 50 for the number of years. Now let me put up a calculator and show you how you can do this. You don't have to have a fancy calculator to do it, but I'm going to show you on my TI calculator. So to start off, actually I'm going to move this over. I would take 1 plus 0.035 divided by 1 and find that value. Oh, I didn't want that to be full screen. Just need to bring it up a little bit. Give me a second while I get a reading on this. Okay, let me show you how you could do this on your calculator. I would take the 1 plus 0.035 divided by 1. So 1 plus, oh, it's not going to work. 1 plus point, is it going to work? 0.03, yeah, never mind. All right, that's not working. All right, plan B. Okay, so we'll do this one more time. I just can't have my calculator emulator up because it won't all show and won't let me work on it on this particular screen. So here is what I would do. You have to follow the order of operations. And, you know, PEMDAS says you have to work within your parentheses first. So you will need to find the value of what's inside the parentheses. In this case, it's 1 plus 0.035 divided by 1. Find that value first. And hey, I've got some parentheses here in the exponent position. Find that value as well. And so we'll rewrite this. So A is equal to 100 times the 1 plus 0.035 divided by 1 is just 1.035. So I'll find that value on my calculator. Then I find the value of the 1 times 50 in the exponent position on my calculator, and that's just 50. So again, I have to follow the order of operations, working inside these parentheses first. Find that value. Work inside these next parentheses in the exponent position, find that value. So here I am. I've got A equal to 100 times 1.035 raised to the 50th power. I can't do the 100 next because order of operations says parentheses, then exponents. Addition, subtraction, multiplication, and division, that all comes after. So I can't do 100 times 1.035. I've got to raise that 1.035 to the 50th power before I can deal with that 100 in front. Well, depending on your calculator, here's a couple of ways it could go. You could type in 1.035, and if you have the caret key, that upside down V, use the caret key and type in 50. Or if you have the Y to the X button or the X to the Y, you would type in 1.035 hit the y to the x, or x to the y. I'll just hit y to the x. I can't remember what it is on most calculators. Type or hit or click that feature, then type in the exponent. Either one of those operations will raise 1.035 to the 50th power. So when you use that feature and raise that to the 50th power, you should get a really long value with a lot of decimals. You should see something like 5.584926856. Now we can take that number, take that result, and multiply it by the 100 in front. So that multiplying by 100 is done at the very end of the problem. Even though it comes first, order of operations, we have to do it at the end. So when I do that, you'll notice that you get, well, shoots, it won't change to black again. Come on, black. There we go. We should get $558.49. Now, very important thing to note when you're doing this. You need to leave as many decimals as shows on your screen when you're working these problems. If you don't, then your value is going to be different than what maybe my math lab wants or what I want or what the bank would do. So what you want to do is when you have these values with decimals, write down as many decimals and use as many decimals as you can. Never round until your final answer. So I guess that is the goal. Never round until you get to your final answer. Does that make sense? Never round until you get to your final, whatever, your final answer. I think you get the idea. At this point, right here at the 558.49, at this time is when I round, and I never round before. Okay, so that'll help you get through these calculations. All right, so try doing this again, using your calculator, practicing using that formula with this situation. We've got $10,000 that's being invested in an account earning 5% interest, compound interest. We want to find the amount in the account after 5 years. So right now we have a principal investment P. We have an APR of 5%. We have the number of years being 5. Now we need to know, well, how many times a year is that interest going to be compounded? So we're going to do it 4 ways. We're going to compound the interest annually. That means N is 1. Quarterly, that means N is 4. Monthly, that means N is 12. And daily, that means N is equal to 365. So you're going to use this formula 4 more times. This should get you some good practice. So practice on your calculator. Whoops. Yikes. Practice on your calculator. Then check your answers. And I have all the answers right below this. So work each one of these scenarios out. See if you get the values I have below for each of those. You've got to become proficient at using your calculator to find these values. So we went up to daily interest being compounded 365 days a year. What if I compounded my interest an infinite number of times per year? What do you think is going to happen? I don't know. Let's check it out and see.